Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today's topic was by the request of a customer. Here it is. Tank volume calculation function blocks. So today we're going to be talking about user-defined function blocks that you can use, that we're going to provide during today's program, to calculate the volume from tanks of various geometries, and this came at the request of a customer. Now, Seascape and the Horner OCS has had the capability of making these calculations and doing these calculations for some time, but these user-defined function blocks are going to make things just much easier. So we really appreciate the requests that we get for topics, and we really enjoy bringing them to you. Okay, so let's take a look at how we're breaking down today's topic. Okay, we're going to do a quick review of what are user-defined function blocks, why are they useful. We're going to go through the tank volume function blocks that we're presenting today. We're going to give you options for cylindrical tanks, oval tanks, and capsule tanks. We're going to spend a little bit of time on the math behind the scenes, but one of the beauties of user-defined function blocks and the fact that I'm doing these and putting them online for Horner customers is that you don't have to worry about the math because I've done that for you. And of course, we're going to have plenty of demonstrations throughout. All right, here we go. Okay, so what are user-defined function blocks? Well, we cover them quite a bit in this channel, and for good reason. These are effectively modularized sections of code that are packaged in a callable function, a little bit like subroutines, but much more powerful. Because unlike subroutines, you can have multiple instances of user-defined function blocks throughout the same program, which is a very useful function. Now, whether you create user-defined function blocks yourselves or whether you import ones that others have made for you, like the ones I'm presenting today, in either case, they are an excellent way to efficiently solve a variety of application issues. Now, they do require that you use variable-based logic, either variable-based advanced ladder, which are the function blocks I presented for you today, but you can also use those in the Seascape IEC options, although these particular function blocks, I haven't done the coding yet for IEC, although I plan on doing it relatively soon. Okay, so why are we creating these user-defined function blocks for the calculation of tank volume, other than the fact that a customer requested it? Well, it's a fairly common practice or a common task to effectively measure the level in a tank and then calculate the volume, whether it's in gallons or liters or cubic meters or whatever the case may be. However, based on the geometry of some tanks, it can be quite a task, at least it involves a fair amount of math in order to make that conversion or to make that calculation. So we thought we would make it easy on you by providing these user-defined function blocks. Again, importing UDFBs into your project, especially ones that are well-tested, that other people programmed for you, it's a way to really save time on your project. Okay, so here are the 6 different tank geometries that we're making available today. Horizontal and vertical cylinder tanks, horizontal and vertical oval tanks, and horizontal and vertical capsule tanks. Now, if you have other tank geometries you're interested in, just give us a note in the comment section, or if you're watching live right now, in the chat section, and we'll get those scheduled. Okay, now before I go any further, yes, I did the coding required to create these user-defined function blocks, but I used a lot of resources provided by the website www.calculatorsoup.com. They had a lot of great information on their site. They had plenty of diagrams, which we used in our presentation today, so those are absolutely courtesy of calculatorsoup.com, and they had a lot of great information on the formulas involved and different techniques. Definitely, I would recommend, just in general, if you're looking to do some technical calculations, to go to calculatorsoup.com and check that out. Okay, now let's spend a little bit of time on the math behind the scenes of these function blocks even though, frankly, you don't have to worry about them because I took care of it for you. Okay, let's start with a horizontal cylinder tank. So really what that's all about, the effort there really, is in calculating the volume of a cylinder section. Because when that cylinder is laying on its side, you can think of it like it's kind of had a knife that sliced through it that basically represents the level of the liquid in the tank. And you have to be able to calculate that volume accurately. And you can see that it involves trigonometry. Okay, we've got sine involved, we've got the arc cosine involved, we have arcs, we have circles, we got all kinds of things going on there. Probably things that some of us haven't seen since the days of geometry, probably sophomore year in high school. But anyway, that's what's involved in the horizontal cylinder tank calculations. And frankly, a lot of the other tanks will use a portion of this as well because they have cylindrical qualities to them as well. Now for a vertical cylinder tank, it's a lot simpler. Basically, it's pi r squared, the area of a circle, which is the circular area of the tank. Multiply that by the fill height, then you've got your volume there. So that one's a lot more straightforward. But again, we have it all done for you through the user-defined function block. Now the horizontal oval tank is very similar to the horizontal cylinder tank. You can just think of it as a cylinder cut in half with a rectangular section in the middle. So we can combine the techniques of a rectangular tank and a cylindrical tank to make those calculations. When we take that same tank but we flip it up vertically, again, it's similar but not exactly the same because now we have to make really 3 different approaches to our calculations depending on whether the level is down in the lower half cylinder section of the tank, whether it's in the middle rectangular section, or whether it's in the upper half cylinder section. So some differences there in the calculation you need to make. But again, we've taken care of that inside the user-defined function block. And then finally getting to our capsule tanks. Here it's really all about spheres, the volume of spheres, whether it's a half sphere, an entire sphere, or the section or a segment of a sphere, which is sometimes called a cap. So as you can see, more trigonometry required here. And then finally, when we turn that capsule vertically, we run into a similar situation as we've seen just a couple minutes ago, in that we have different calculations based on if we are in the lower half sphere, the middle cylindrical section, or the upper half sphere. Okay, so those are the 6 different tank geometries we're covering today. But again, the user-defined function blocks are going to do the work for you. So we need to show you how to use the user-defined function blocks. So really the process, which I'm going to demonstrate here in a couple minutes, is as follows. You're going to import the UDFB file into your project. You're going to add an instance or multiple instances of that function block into your logic. As you assign each instance or add each instance to your program, you are going to assign variables to it. It's got input variables, it has output variables. All the input variables, save one, are in floating point format. And the output you get from the output variables is going to be in gallons, liters, and percent filled. So regardless of whether you're really looking for imperial or metric type volume measurements, or whether you're just looking for the percentage that the tank is filled, you'll get those from the output of each of the user-defined function blocks. Okay, without further ado, let's take a look at our demonstration. Okay, let's take a look at how we can use these user-defined function blocks that we've created for you. Okay, so I'm going to start with a fresh program. You don't have to do this, of course. You can import it into an existing program. The only requirement is you're going to have to be using variable-based advanced ladder or IEC. Now, these specific UDFBs I've created are for variable-based advanced ladder. I could very easily create the same ones for IEC, but I haven't done that yet. Okay, so I'm going to select a variable-based advanced ladder program. The reason that we have to be using VBAL is because of the fact that one of the requirements for user-defined function blocks is that you have a variable-based language. And register-based is not variable-based, so that's a requirement there. Okay, so I've just created a brand new program. Again, you could easily do what I'm going to be doing, but importing into an existing program. Okay, so I'm going to go to the logic modules here, right-click and say Import Logic Module. Then I'm going to navigate to the folder containing my UDFB files, and I'm going to locate them by searching for, or at least filtering for, a .cpu file, and here they all are. So let's say that we're going to be doing a horizontal cylinder type tank, maybe multiple horizontal cylinder type tanks. Remember, we can have multiple instances of these function blocks in our program. So I have imported it, and it shows up here under horizontal, or HORZ_CYL. Now, you may notice that I'm looking at the logic inside of this UDFB. Now, I don't typically hide the logic just because I want customers to be able to see the logic that's been created. However, usually if you're using a user-defined function block, you really don't care about the logic inside of it. So I'm going to go ahead and close this tab and just treat this like a function block or a black box where I don't really care about the logic on the inside. Okay, now if I want to add this to my program, all right, I'll start out by, I'm going to need to add it to an existing rung. For now, I'm just going to use the always on contact, okay? And then I'm going to find in my toolbox under UDFBs, I'm going to find all the imported function blocks. And so far, I've only imported one. I can import many, that's not a problem. I'll go ahead and drag it here on my desktop. Now, I do have to name every instance of this function block that I'm going to use. So in this case, maybe I have 4 tanks. So I'm going to call this tank 1, maybe, because maybe that's the name of the tank, and I'm going to call it tank 1 volume. There you go. So it's just like I'm naming a variable. I'm just naming the instance of this particular UDFB, and yes, it will show up in my variable list if I look for it. Okay, so it's now been created, this instance has. Now I just need to fill in the variables for all of the inputs and all of the outputs. Now with these UDFBs that I've created, these all happen to be using real variables for the diameter, the length, and the height, along with the outputs of gallons, liters, and percentage, with one exception, and that is the units_m input is a Boolean. So if that is on, then I'm going to be using metric or meters for my linear dimensions. If it's off, I'm going to be using feet for all of my linear dimensions. Now, regardless of whether I select feet or meters, I'm going to get gallons and liters and percentage that the tank is full. And maybe I don't care about gallons, or maybe I don't care about liters, but I'm going to get all 3. All right, so I just fill in the variables, assign the variables from my existing program. In this case, I've got a new program. So I would start, since it's a brand new program, I guess I can assign these on the fly. And I could assign a variable here called tank 1 diameter, for instance. Okay. And then I could, again, create it on the fly, assign it as a real variable, because that's what it is. It would probably make more sense for it to be a retained variable. All right, and then I would do the same with all of these variables. Now, I could also just type the values in. I don't have to have variables assigned to all of these inputs. For instance, I could just say, oh, the length is 10 meters and the height. Of course, the fill height is absolutely going to be a variable. That's the input from your sensor. And then maybe I'm always going to be using feet. Okay, so I could make this always off. So it is a Boolean variable, but it's always going to be a 0, so therefore I know that my units are always going to be in feet on the input side of things. Okay, so I would go through and assign each of the variables in turn, or for the ones that don't have to be variables, like diameter and length, for instance, I could just type those in as constants. All right, so that's how I use the user-defined function block. I basically import it, drop it in my project, assign variables to it, or constants as the case may be, and away you go. All right, so that is using the UDFB. Now I'm going to go ahead and close this project and show you my demo program that will be posted for you to download and take a look at if you choose. Okay, and this is a program that actually uses all 6 of the user-defined function blocks for the tank volume. They've all been imported over here. Okay, and in my main logic, you can see I am calling each of them in turn. Each of them is called with a push button on the touchscreen. And on each of the screens, I'm showing a diagram of the tank along with the data that can be typed in, along with the results from the function block of gallons, liters, and fill percentage. So pretty handy. And then you can just go through all the 6 different take geometries and see how those work and plug in numbers and away you go. So let's just look at a couple real quick. All right, so over here on the bench, you can see I have my cylinder tank. I've got my diameter plugged in as 3. Now everything's in feet because with my demo program at least you can switch back and forth, but right now from the screen you can see that it's in feet. My diameter is 3 feet, my length of the cylinder tank is 6 feet, and my fill level I've just plugged in as 1. Normally you'd have a sensor connected there. All right, and if I hit the calculation button, all right, you can see there's my calculation of gallons, liters, and fill percentage. All right, and then we've got the same exact functionality for each of the different types of tanks. Let's take a look at a horizontal capsule tank. All right, so we've got our diameter of 3, our length of 6, and our fill level of 1. And if we hit the calculation button, okay, we can see, there we go, 119.99 gallons. There's the number of liters, and there's the fill percentage. So pretty straightforward stuff. I would encourage you, if you're going to be using these user-defined function blocks, to go ahead and download this program and play with it a little bit so you're super familiar with the operation of everything and the geometry of everything before you start using it. Okay, well that wraps up our content for you today. We hope you will find these function blocks useful, and if you have a tank geometry that you'd like to see us add to the list, just let us know in the comment section if you're watching on replay, or in the chat section if you're watching us live. Okay, we're here every Tuesday at 2 o'clock, whether we're fully live like we are today, or whether we are pre-recorded. Next week I will be traveling, so we will be pre-recorded, but we'll have folks standing by as we stream the video live, ready to answer any questions you might have. Okay, we've got a training class going on this week, so you've missed that one if you're watching this live, but we have plenty of other classes scheduled for the rest of the year. Sign up on our website. There are lots of ways to interact with us online to get your automation needs taken care of. You can touch base with us on our website at hornerautomation.com, on our Horner APG YouTube channel where you'll find all these videos, and also feel free to interact with us on LinkedIn as well, because we're definitely active there. Okay, so June and July represent the summer of Seascape 10, because hint, hint, Seascape 10 is imminent. So you're going to want to check our website for all the details on all the Seascape 10 related topics coming up over the next couple of months. But I can tell you with absolute certainty, the first in the series, the Summer of Seascape 10, will be covering the Seascape 10 user interface. So we're going to go through all the great enhancements and changes that have been made to the user interface portion of Seascape 10. The way that you interact with the software, the way you edit your logic, the way you edit your screens, the way you set up your desktop. We're going to go through all of that with you next week. So don't miss it, and don't miss the Summer of Seascape 10. Okay, if you haven't done so yet, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week when we start our series on Seascape 10, let's all get out there, enjoy our summer, and do us some good.